Hello everyone. Today we shall discuss about oscillations. Here from orbits to oscillations. From orbits to oscillations. Analyzing the mathematical distinction between periodic motion and simple harmonic motion. Let us find the difference between the periodic motion and simple harmonic motion. The inverse repetition. Periodic motion is defined as any motion that repeats itself at regular intervals of time. That is periodic motion. The defining characteristics is time, not path. If it resets the clock, it is periodic. If it resets the clock, it is periodic. So, the periodic motion is defined as any motion that repeats itself at regular intervals of time. Chaos and curves in periodic systems. Periodic motion allows for arbitrary paths. It does not require equilibrium. Right? Periodic motion allows for arbitrary paths. It does not require equilibrium. The Earth repeats its orbit every 365 days. It is periodic. The hands of a clock, it is also periodic. That is circular path. It is also as defined as periodic. All subsets of relationship. All simple harmonic motions are periodic, but not all periodic motions are simple harmonic. So, simple harmonic motion is a subset of periodic motion, right? So, a special case is strict mathematical condition. Simple harmonic motion follows strict mathematical conditions. Now, we'll find what are the various conditions for simple harmonic motion. Defining simple harmonic motion, a special type of periodic motion involving to and fro movement about a mean position. That is simple harmonic motion. Unlike the free roaming planet, simple harmonic motion is tethered. It oscillates across a central equilibrium point. So, it is known as simple harmonic motion. Here equilibrium position is the mean position and it's oscillating to and fro. So this type of motion is known as simple harmonic motion. The distinction at a glance. If we distinguish between periodic motion and simple harmonic motion, we are getting this one. The restoring force not always present in case of periodic motion. Simple harmonic motion always present. Force is proportional to negative displacement, that is F is proportional to minus of x. Path, circular, elliptical or linear. Periodic motion may be circular or elliptical or linear, and simple harmonic motion is straight line or arc for small angles. Feature mathematical form, any periodic function, that is periodic motion, and simple harmonic motion sinusoidal, that means either it is a sine curve or it is a cosine curve. Either it is a sine curve or it is a cosine curve. The engine of oscillation. I already told you that F is directly proportional to minus of x. That is, F is the restoring force always present. Proportionality, force scales with displacement. The negative sign, force opposes displacement, putting the object back to the center. Here you see that is displacement x is negative, vector, force vector arrows points positive or right. Equilibrium, x is 0, force is 0 at this point. Displacement x is positive, the vector force vector arrow points left or negative. So this is the type in which we find the oscillation, and oscillation is the restoring force is directly proportional to negative of displacement. The sinusoidal signature. To qualify as a simple harmonic motion, the motion must map to a sine or cosine function. So this is a pendulum moving in this way, and theta is very small. So the sinusoidal map will be like this. This is displacement, this is time, and this is the curve for a simple harmonic motion. Right? This is a curve for a simple harmonic motion. This is displacement and this is for time. So The curve for a simple harmonic motion is either sine curve or sine function or cosine function. Constraints on the path. Periodic motion, simple harmonic motion can be a closed path, must be straight line. In simple harmonic motion must be straight line. Note, a simple pendulum is only considered simple harmonic motion at small angles where the arc approximates a straight line. Where the arc approximates a straight line. What is simple harmonic motion? Simple generally must be straight line, but it can be a closed path along a periodic motion. Defining acceleration in simple harmonic motion, A is equal to minus omega square x. This is the equation for simple harmonic motion. The acceleration is equal to minus omega square into x. Here you see that acceleration is always directed towards the mean position. Magnitude is proportional to displacement. This is the velocity is maximum here and the acceleration is max at this point, right? So we can find this, the velocity is maximum at this mean position, right? And acceleration will be maximum at the extreme position. So A equal to minus omega square into x. Next one is the conservation of energy. In ideal SHM, simple harmonic motion system, frictionless, total mechanical energy remains constant, transforming between the kinetic and potential. So if we get the kinetic energy, this is the curve for kinetic energy. This is the curve for kinetic energy. This is the curve for kinetic energy. And we find the potential energy. This is the curve for potential energy. This is the curve for potential energy, and the total energy will be kinetic energy plus potential energy, and you see the total mechanical energy is always a constant factor, right? So the total kinetic energy is always constant. You see, this is total mechanical energy, this is constant. So in ideal simple harmonic motion, frictionless, the total mechanical energy remains constant, transforming between kinetic and potential. This is the earth is periodic, not simple harmonic motion. Misconception. Not simple harmonic motion. This is simple harmonic motion. So repeats every 365 days, no resting force toward a mean position. So this is a not simple harmonic motion, right? This is periodic. So this is known as periodic. So it is known as periodic. Moves back and forth, resting force pulls towards the center. Therefore this is simple harmonic motion, SHM. This is not a simple harmonic motion, right? It is not a simple harmonic motion, it is periodic, but it is simple harmonic motion, right? This is correct. So now we'll go to the next one, next thing, that is this one, Summary of motion. Periodic motion occurs at regular intervals. No constraints on force or path. Example, clock hands, planetary orbits. These are examples of periodic motion. Simple harmonic motion, SHM, is strict subset of periodic motion, to and fro movement. It is subset. So this is the periodic motion, and simple harmonic motion is a subset of periodic motion. Force is proportional to displacement, that F is directly proportional minus of x. Examples, springs and pendulums are examples of simple harmonic motion. All simple harmonic motions are periodic, but not all periodic motions are simple harmonic. You have to remember that all simple harmonic motions are periodic, but not all periodic motions are simple harmonic motion. This is further reading. For deeper definitions and mathematical derivations, refer to the official Ncert physics textbook, that is chapter oscillation. So we have defined the difference between the periodic motion and simple harmonic motion. What we find at the end, that simple harmonic motion is a subset of periodic motion. So simple harmonic motion is a special type of periodic motion, right? Thank you everybody for watching this video.